For example number 5, we need to kind of think about the intermediate value theorem. And Mr. Adams, you'll hear me say IVT. Not every function can be a derivative, and a derivative must have an intermediate value property as stated. And so I'm going to read the formal definition of it, and then I'll try to explain it in regular English. It says, if A and B are any 2 points in an interval on which f is differentiable, then f prime takes on every value between f prime of A and f prime of B. Now what that means is if I look at a graph and the graph is differentiable from A to B, 2 points on the curve, then f prime is also defined between A and B. So if the original function is differentiable, that means we can calculate a derivative from A to B and every point in between, then we should be able to define the derivative at that value. It's kind of common sense, but the formality of it can be confusing sometimes. So for example number 5, it says, does any function have the unit step function as a derivative? And the answer is no. And how do we know this? Choose sum A less than 0 and sum B greater than 0. Then u of A equals -1 and u of B equals 1. Your u of B equals 1, but u does not take any value between -1 and 1. What are they saying? What they're saying is that if you choose a step function and you let A equal a negative number and you let B equal a positive number, then because of the step function there are no values in between them. Now the question of when a function is a derivative of some function is one of the central questions of all calculus. The answer found by Newton and Leibniz basically revolutionizes mathematics. But a step function, and this was the key, and this is why we talked about it so much, the step function has what we call jump discontinuities in it. So it's not continuous. And because of the jump discontinuity, it's not defined from A to B. Well, I mean, it's defined from A to B, but the derivative is not defined. So the step function could never be a derivative of another function. So now we're thinking backwards. Does that make sense to you guys? Okay.